Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi. Today I would like to present mathematical reasoning task 3. So let's move on to the question. And this question is: a group of 24 students is assigned to design a rectangular community garden surrounded by a uniform walking path. The total outer area including the path is 200 square meters, while the inner garden area is 120 square meters. The length of the garden is 2 meters longer than twice its width. Let the width of the garden be meters. Form an algebraic equation to represent the total area and determine the width of the path. Find the dimension of both the garden and the entire outer rectangle, and calculate the perimeter of the whole area. Represent the relationship graphically with label dimension. If each student is responsible for an equal rectangular plot of herb within the garden, determine the area of each student's plot. Finally, suggest how the equation would change if the path were twice as wide on the one side only, and explain your reasoning using algebraic expression. So, we use folia 4 step of folia, which is understand the problem, devise a plan, carry out the plan, and look back, and combine with algebraic manipulation and quadratic equation. So, first step is understand the problem. The problem is to determine the dimension of rectangular community garden and its surrounding uniform path based on area constraint and a specific relationship between the inner dimension. So, the key given information is total outer area, which is a total. Garden plus path is 200 square meter square. Inner garden area 128 meter square. Inner dimension relationship, L represent length, is 2 meter longer than twice the width. W represent width. So L equal 2W plus 2. Path uniform width denote ST. The task is find WLT, calculate perimeter, determine student plot area, and model a non-uniform path change. So step 2, devise a plan, which is the strategy that we are using to solve the problem. So the solution requires two primary stages, each involving a quadratic equation. First is solve for inner dimension, W and L. Use the inner area constraint, L multiple W equal to 128, and the L divide W relationship to form a quadratic equation in W. Next, solve the path width, which is T. Express the outer length, L outer equal to L plus 2T, and outer width, W outer equal W plus 2T, using the result from step 1. And use the total area constraint, which is L plus 2T, multiply W plus 2T equal to 200 to form a quadratic equation in T. And the next, final calculation and modeling. Calculate the perimeter area per student, and modify the total area equation based on the non-uniform path scenario. So the next step is carry out the plan, the execution. And first step is finding inner garden dimension. We need to substitute and form equation, which is substitute L equal to W plus 2 into the area formula. So it's be 2W plus 2 close bracket W equal 128. So it's become 2W square plus 2W minus 128 equal to 0 in the power of 3. and then we need to simplify by dividing by 2. W power of 2 plus W minus 64 equals 0. And step 2 is solve for W using the quadratic formula and taking the positive roots, since dimension must be positive. So we just insert the information in the quadratic formula. So W equal to minus 1 plus square root 1 2 power of root 1 square minus 4 multiply 1 multiply negative 24 divide by 2 and is be negative 1 plus square root 257 divide by 2. So W is 7.516 meters. Step 3, solve for L. Using L equal to 2W plus 2. So L is 2 multiple 7.516 plus 2. So L is 17.032 meters. And then for the B and the B, we need to find the path width, which is T, and final dimension. First step, form the total area equation. Substitute the fixed L and W into the outer area formula, which is L plus 2T multiply with W plus 2T, so is equal to 200. And then so we have got L is 17, so we just put this value to the formula. So we got 17.032 plus 2T multiply 7.516 plus 2T is equal to 200. And then step 2, expand and simplify. Expanding the expression give 128 plus 49.0960 plus 40 square equal to 200. So the quadratic equation 40, and we need to rearrange into standard form, and it's be 40 square plus 49.0960 minus 72 equal to 0. And step 4, solve for T, applying the quadratic formula to this equation. And so T we got 1.324 meters. So step 5, calculate outer dimension. Outer length L outer equal to 17 plus 17.032 plus 2 multiply 1.324 equal to 19.680 meters. And then for the outer width, we let W outer equal to 7.516 plus 2 multiply with 1.324 equal to 10.164 meters. And then the next is final calculation. So we need to find the total perimeter, which is P total. P total equal to 2 multiply L outer plus W outer. So it's equal to multiply with 19.680 plus 10.164. So it's equal to 59.688 meters. Step 2, we need to find the area per student plot. So the area is 128 meters square. Divide 44 students, and is equal to 16/3. So 16/3 equal to 5.33 meter square. The graphical representation. The resulting plans show a garden of 17.03 meter by 7.62 meters surrounded by a uniform path of 1.32 meters, and then creating a total area of 19.68 meters by 10.18 meters. So the next step for polia is look back. We need to do verification, which is check. So the inner area 17.032 multiply with 7.516 equal to 128 meters square, and is correct. And for the outer area we need to multiply 19.680 with 10.164, so it's equal to 200 meters square, and is also correct. So the all dimension L, W, T are positive and physically meaningful. So modeling non-uniform path change. The equation asks how the equation would change if the path were twice as wide on one side only. So for the algebraic expression change, the inner dimension L, W are fixed. For the outer width W outer, the width side remain T, and T equal to W outer equal to W plus 2T. So there is no change over there. And for the outer length L outer, the length side are T and 2T. So for the L outer equal to L plus T plus 2T equal to L plus 3T, and there is change. And the next is new total area equation. The original equation which is A total equal to L plus 2T multiply with W plus 2T is replaced by A total which is L plus 3T multiply with W plus 2T. So the reasoning is the path contribution to the line dimension increases by any additional T. The equation must reflect the new geometry while still equating the total outer area of 200 meters square. And that's all from me. Thank you.